Hello everyone and welcome back. My name is Zek and today we're going to be learning about indexes in SQLAlchemy. Indexes are powerful tools for optimizing database queries, but they also come with some trade-offs. So let's get right into it. First, let's talk about what an index is. In the context of databases, an index is a data structure that improves the speed of data retrieval operations on a database table at the cost of additional writes and storage space. So let's see an example of how an index works. Here we have a users table. Let's say we want to find the user with the ID of 10. Whenever we perform a query without an index, it will perform a sequential scan over each row until it finds the data we are looking for. And so in this example, it scanned 10 rows to find the row with an ID of 10. This is not bad for small datasets, but for large datasets of millions or even billions of rows, this can be extremely slow. There's a couple different ways indexes can be created. One is using a B tree, which is a binary tree. And this will take the value that we're indexing. So let's say we put an index on the ID column, and it converts it into this binary tree. So most relational databases will use this binary tree structure for indexing. These are sorted as you can see here on the screen. Each node in the tree contains the ID value and the reference or a pointer to the actual row in the table where the ID resides. And so with this diagram, if we query for a user with an ID of 10, it first checks the topmost node to check if the value we are searching for is referenced here. It's not, and the value of 10 is greater than the value of 8, so we move to the right and check if this next node is the same or not as the value we're searching for. This happens to be the value we're looking for, so we get the reference to the spot in the table and return that row data. And you can see here we basically only check 2 nodes instead of 10 rows on the table. This speed difference is pretty much negligible for this situation, but for larger datasets, it will be a big improvement. Let's look at another example. Let's say we want to search for the ID of 7. Searching for this ID is going to be the exact same process. We first check the topmost node of 8. We see that 7 is greater than 8, so we go over to the left to number 4. 7 is greater than 4, so then we go to the right. 7 is greater than 6, so we go to the right again. And 7 equals 7, so we have our node. Grab that reference and return the data. And so even in this case, for the ID of 7, we only searched 4 nodes to get to it. This is basically how an index works. There are some scenarios when you might want to add an index. If you often query a table using a specific column or set of columns, adding an index can make those queries much faster. So an example of this is searching for users by an email in a users table. If you frequently join tables on specific columns, indexing those columns can improve join performance. So if you have a users table that joins with a post table, indexing the columns like the user ID foreign key can help improve that performance. If you frequently use the where clause or the order by on specific columns, indexing these columns can improve performance as well. So if you're trying to filter out post by date, then indexing the date column can help improve the performance. If a column must have unique values, a unique index enforces this constraint efficiently. An example of this is making sure that usernames or emails in a user's table is unique across the whole table, so there are no duplicates. If you frequently perform range queries on a column, such as finding all the records within a certain date range, indexing the column can help. So getting all the posts from a user within a certain date range is a likely scenario for this. There are, however, some situations when you don't want to add an index. If you have really small tables, the overhead of maintaining an index might not be worth the performance gain since the database can quickly scan the entire table. Having indexes on columns with few unique values, or low cardinality, might not provide significant performance benefits, and it can consume unnecessary resources. So for very small tables, you're not really going to see a huge performance increase. So an example of this is having a column that has a true or false value on it. If your application performs a lot of write operations, such as inserts, updates, and deletes, too many indexes can slow down these operations since the indexes need to be updated as well. For frequent batch operations like bulk inserts or updates, sometimes it's better to drop the index before the operation, do the operation, and then recreate the index afterwards. Now let's see how to create indexes using SQLAlchemy. So here we have our setup with all of our imports at the top. We are creating our engine and we are using SQLite for this example. And we are creating it in memory so we don't have to keep deleting it and recreating it each time I want to make changes. This was pointed out in the comments and is a great idea. So here we are creating our base class, inheriting from declarative base, and we are giving it an ID that will be a mapped column as a primary key equaling true. Then we'll go and create a users table with a name and email. And so perhaps the easiest way to create an index on one specific column is to come over into the mapped column and type index equals true. If you haven't created your table already, whenever it goes ahead and creates it, it will then create the index on this column. If you already have these tables created and then you add this in there, it won't apply the index unless you recreate the tables or you use some kind of migration system, such as Alembic. If you are using the legacy style of creating columns, all you have to do is pass index equals true into your column. Another way we can create the index for a specific column is to use the index class. So we can do this by having some variable name. In this case, I have username index equaling the class index. The first argument you pass is the name of your index. Generally, there is some kind of naming convention. So here I have ix underscore, the table name, and then the column name. But depending on what kind of code bases you're in, it might be different. But after the name of our index, we then pass the column we want to put the index on. So in this case, we're doing user.name to put it on this column right here. My apologies, we actually have to have this code below creating the tables. So that way it can then apply this index on it. And so once we have our index, we then create it, binding it to our engine, which will be our SQLite database inside the memory of my computer. So we'll go ahead and run this file, and we can see there was no output, so that's good for now. Doing this does create the index, but if you tried to duplicate this or run the same script again, creating the index, it will then go ahead and throw an error saying that the index already exists. We can do a check first to see if the index doesn't exist, and then go ahead and create it if it doesn't. So we can do that by adding the argument check first equal to true. So if we go ahead and run the script again, we can see there was no output down here, meaning that it did work. If you wanted to remove an index, instead of create, you would have drop. So if we go ahead and run this as it is, there is no output, meaning that it did create and drop it successfully. But if we did try to drop it again after we already dropped it, it is going to throw an error saying that the index does not exist. We can then pass the same argument, check first equal to true, to see if it exists, then drop it. If not, then don't do anything. So we go ahead and run this again, and there is no output, meaning that it worked. We can add some code to see the indexes on our tables in our database. So here I'll do it by adding this code down here of base.metadata.reflect, and we'll bind it to the engine. This will get the current status of all of our tables in our database. And so once we have that, we can then iterate over the items of the tables, which will be a dictionary. We'll print the table name, get all the indexes. If there are no indexes, print no indexes. But if there are indexes, then we will loop over each index and the columns they are associated with. So we'll go ahead and run this again. We'll pull up a terminal. Then we can see it is printing out the users table. And we do have an index of ix user's name on the column of the name, which is exactly what we have right here. Another way we can create a basic index is to come into our users table specifically, and we will use this double underscore table underscore args double underscore, and it will allow us to add some more configuration to our table. So in this case, we can add things like indexes or other unique constraints. So here we give it the exact same index that we had down right here, except in this case, instead of doing users.name, we just pass the column name of name. So we'll go ahead and get rid of this right here. And then we'll go ahead and run this again. There we go. So in this index right here, you do have to add a comma to make this into a tuple. We'll go ahead and run it again. And we can see it did print out table users with the index here and the column it's on. So next we'll look at composite indexes, which involve creating an index on multiple columns. And so we can do that by passing more than one column name into this index class. So let's say we want to have an index on name and email. Then after this name right here, we'll add a comma, then type email. And the name of this index will be a little bit different. We'll just add another underscore email at the end there. And we'll go ahead and run this again. And we can see on our users table, it did create that index, and it has both the columns name and email associated to it. And so creating the index like this creates one index using both the columns of name and email. And this would be different than this, where we have two different indexes, one using the name column, and the other one using the email column. And so another index that you probably don't know you're already using is the primary key index. Most relational database management systems, or RDBMS, automatically create indexes for primary keys as a standard feature. And these are created as unique indexes on the column. So here where we have our ID, this is already created as a unique index. The primary key index is not visible to us with the way we're viewing indexes on the table. Next, we'll look into foreign key indexes. So some databases like MySQL will automatically create foreign key index when you add a foreign key to a table. But databases like Postgres, SQLite, and Oracle will not. So we will have to add the index for that column explicitly in order to create the index. So here's an example of users to posts, where the users have a relationship one-to-many of posts. And we do have the user ID as a foreign key to the users table. And here we are adding index equals true, since SQLite does not automatically apply an index to this foreign key constraint. So we can go ahead and run this again, and we'll pull this up here. And we can see our users table does not have any indexes, but our post table does have an index right here. And the last one we'll get into in this video is the unique index. And so unique indexes can also enforce uniqueness on columns. So let's say we want to make sure all of our users in our users table has a unique email that can never repeat. So we can just do that by saying unique is equal to true. Now, most databases like Postgres, MySQL, and Oracle will automatically create a unique index, but SQLite will not, so we will have to add index equals true onto this column. And we can verify that by going ahead and running this file, and we can see that no indexes have been applied, but we will go ahead and add this index equals true argument and run it again, and we can see the index was now applied. And there you have it. We've covered the basics of creating indexes in SQLAlchemy. Indexes are powerful tools for optimizing your database queries, so use them wisely. If you found this video helpful, be sure to like, subscribe, and hit the notification bell for more content. Thank you so much for watching, and I'll see you in the next one.